Listen up, guys. Gen Chem 2 is hard. Only 35% of the class got this correct on the first exam. We're here to make sure you get it right. First, let's write down the givens. We have 1 mole of unknown A with a V pressure of 265 torr, and 3 moles of unknown B with a VP of 355 torr. We know that the total VP is 354 torr. Raoult's law states that the VP of solution equals the mole fraction of A times the vapor pressure of pure A, if we have a volatile and a non-volatile component. Since we have 2 volatile components, the equation is P of solution equals XP pure A plus XP pure B, where we represent X as the mole fraction, which we'll have to calculate for both A and B. To do this, we divide the moles of A by the moles of solution, and do the same for B. The second variable represents the vapor pressure of pure substance. With both A and B's mole fraction and their respective vapor pressure in their pure forms, we can do a plug and chug and solve. The total vapor pressure of the solution is 333 torr, which is only precise to the first place. But this is less than the given value of 354. What does this mean? To interpret this, you need to understand positive and negative deviations. Let's think of these as personality types. Positive deviation happens when introverted and extroverted people are attracted to only people like themselves. An introverted group of solutes might enjoy spending time with other solutes, doing activities like reading, while an extroverted group of solvents might enjoy partying together instead. Negative deviation occurs when the introverted solutes interact with the extroverted solvents and form a unique third group. Let's look at this relationship as a graph. First, imagine the vapor pressure of A on its own graph. We're just using this graph and lines to emphasize this concept. This problem does not actually give us enough information to graph it on its own. The x-axis of the mole fraction of A in solution from 1 to 0, and the y-axis is the vapor pressure exerted by A over the solution. Now let's think of this vapor pressure of B on its own graph. This time the x-axis is the mole fraction of B from solution from 0 to 1 instead. You'll see why we do this later on, but the y-axis is vapor pressure. This is the vapor pressure exerted by B over the solution. Now that we have these two graphs, let's superimpose both graphs on top of each other. Since we reverse the x-axis for B, the mole fraction of A and B line up perfectly. If we draw a line connecting the vapor pressure of A to the vapor pressure of B, we obtain the total vapor pressure of the ideal solution. As you can see, it's a straight line, just as Raoult's law of linear relationship states. Because our calculated total vapor pressure is less than the given value, we see this as a positive deviation from Raoult's law. Remember our introverts and extroverts? They are the reason the solution does not exactly follow this linear relationship. Positive deviation occurs when introverts and extroverts stay in their respective groups and don't intermingle. So the graph deviates from the linear relationship. This is because the solute-solvent attractions are weaker than the solute-solute and solvent-solvent attractions. Negative deviation occurs when the introverts and extroverts mingle. They cause the solution's actual VP to decrease. Thus, solute-solvent attractions are stronger than the solute-solute and solvent-solvent attractions. Because we know all of this, answer choice C is correct. Let's break down why the other answer choices are wrong. Choice A is incorrect because our total calculated VP of solution does not match the total VP given. Choice B is incorrect because this is a negative deviation, which is the opposite of what we just found. Choice D is incorrect because B has a higher vapor pressure than A, making it more volatile. Choice E is incorrect because the VP of A is lower than the VP of B, and liquid A would have to have a higher boiling point. This might seem like a lot, but whether you're introvert or extrovert, if you follow these steps, you're sure to get the question right. Good luck on your exam!